Hey, Evelyn. Evelyn, can you hear me? Okay, I see you. I just can't hear you. There you are.
There we go. Can you hear me?
Yep, I can hear you. All right, I'm just gonna walk through problems. How are you
A
feeling about
question.
this exam so far?
Mm, I have a question though.
Okay, what's the
Do you know
question?
who's going to the Costa Rica trip?
I don't. I know. I
It's
think
random.
Sam going.
I don't think so.
I think Ion is going.
I can figure out. I know Ion's going.
Keon, like you said. Um, I think like 12 freshmen. I mean, 12 sophomores want to go. So I think it's the Asian crew.
Is the Asian crew gonna go though?
I don't know. You should ask Dr. Rivas though.
Oh, I'll talk to this.
Ask Dr. B if you don't want Dr. Rivas to be like, why you want to know?
I
I
guess.
feel like he'd be like that. Are you still like undecided a little bit? Yeah.
I think so. I don't know.
Yeah, I realized for me that school starts in July. Like both TCOM and Incarnate Word start in July. So I was like, I want to spend time with my family. No. But yeah. Anyways, let's get started. But do you have any questions to preface anything? Like, how do you feel so far? Like, your what is your weakest or what is your weakest topic right now? Or we can just
Vectors.
walk the problems, like
Just vectors.
vectors.
Vectors and
Okay,
forces. The difference between like the horizontal ones and
okay,
then
I was gonna
the
say like
with
so yeah,
the wave.
I have two questions that focus on that, so we can actually do those first if you want to do that first. Are you feeling okay with 2D kinematics and all that? Okay, then let's skip this first super long question and let's go to kind of vector stuff so that in case you need to leave early, you can leave. Okay, I'm gonna skip this, all of this. Blah. Okay, here's like an example vector question that was on my exam from 2 years ago. And so this is, I don't know, she's probably gonna make it harder, or she's probably gonna have other, or maybe ask it in a different way since like chapters 3 and 4 and 5, it's like a lot of information. And so she will probably test this in the context of forces. Like she'll ask a question force related because it involves doing all this vector stuff. But I'm just gonna start off with like this vector problem. Just try to solve. Do you want to try to solve it, or do you just want me to walk through it?
I'm gonna try it and then
Okay.
we'll see.
How much time do you think we need? I'm gonna do like 3 minutes, maybe more. Like this takes me, I think, 5 minutes to do. So I'm gonna put 4 minutes, and then just shout at me if you have any questions. Oh, I see that Danny and Andrew joined too. Hi, y'all. We're actually going to jump. If y'all have the blank slides open, we're going to start with vector addition. So while Evelyn is solving, I'm sorry, I did not see y'all show up. I don't know what's up with my Zoom, but this is the exam 2 review. Our agenda is that we were going to start with chapter 3, kind of hit the major points of chapter 3 that she could ask about, which is really going to be 2D kinematics with all those equations that you plug in, the motion graphs, which I don't know if y'all touched on too much, but it's like very brief. And then the resultant vector addition and all that stuff. And then chapters 4 and 5 are going to be like forces and all the stuff that they encompass. So we're going to skip everything right now because I'm sorry I didn't see y'all come in, but we're going to start with vector addition with this airplane problem. So try solving it. I think we have about 3 minutes left on the clock. Just try to get it started and set up so that kind of when we break it down, like maybe you have any questions that you could ask me and stuff like that. Okay, beautiful. That is the timer. Okay, let's walk through this. That was okay, honestly, I don't think that was enough time. And also I'm frozen in seventh grade. So I'm gonna start walking through it, and at any time, if you see a place where you like had questions or you kind of like paused and didn't know how to continue, just let me know and we can just let me know how I can help you, okay? And so an airplane flying parallel to the ground undergoes two consecutive displacements. The first is 75 kilometers, 35 degrees west of north, and the second is 155 kilometers, 65 degrees north of east. What is the total displacement of the airplane? So first, I think to start breaking down this problem, we have to consider like, oh, do I know what north, east, south, west is, right? And so I'm just going to draw like a coordinate that we have to reference here. It's really ugly. Never eat soggy worms, sure. Okay. And then we have some new information, right? We have two consecutive displacements. And then we have the first is 75 kilometers and then 35 degrees west of north. So what I like to do in this case is they literally tell us that there's two consecutive displacements. So I'm going to break this problem down into two parts. And then the first part is going to be number one, which we're going to also call A. So I'm going to draw the coordinate plane again. Now there's many different ways of doing this problem. I would say there's like two ways of doing it. There's like the traditional way where you see in your textbook where there's a lot of things going on kind of in one diagram. But in this case, I kind of want to break it down and show y'all how I do and see if it's something that makes the understanding a little bit easier. It's a little bit less error prone. And so first it's 75 kilometers, 35 degrees west of north. So west of north means that I'm going to start in the north and I'm going to go west because we're west of north. or west, or I like to say west from the north. I think that's like easier. It kind of clears up any misunderstandings that may occur when you're trying to solve this. So west of north. So I got this. This is 75 kilometers. And then we're told that this little angle right here is 35 degrees. 35 degrees. Okay. The next part is the second piece of
How
information
did
that
you know
they
the angle was from the north?
because it says 35 degrees west of north, so it's kind of like west from the north. And so we start from the north and then we go west, and then that's the elapsed travel space between that is going to be 35 degrees. Does that make sense?
Okay. So it's not going to be an angle off the x-axis.
Off. Let me. I will come back to that. That's a good question, Evelyn. I will come back to that. Okay. And so the next one is going to be here. And so we're going 155 kilometers, 65 degrees northeast. So from the east, we're going to go north again. And this is going to be 155 kilometers. And this little angle right here is going to be 65 degrees. I don't like this. 65 degrees. And so we kind of have this first set up already. And at this point, what do I usually do? At this point, we kind of reflect on what they're asking us, which is the total displacement. We kind of have these two movements that build up to the final displacement, right? And so I like to have a thing that I set up right after I set everything else up for the problem, and I call it like the ultimate triangle. Like and you will hopefully see its purpose in the future, but okay, I'm gonna call it the ultimate triangle. We'll go back to this. So going back to 1A or triangle movement A, we are told that the plane is moving that way, right? So we know that in order to find the ultimate displacement and total movement of the plane, we need to find kind of the components of each of these triangles, this one and number two. And so like Evelyn said, one kind of shortcut that I like to take to make sure everything is less error prone is to take everything from the x-axis right here. And so this angle, y'all are familiar, right? Like when in class, she's like, oh, you find A and then you find AX by doing A cosine theta, and the A1 is equal to A sine theta. So this is like a formula that you should have on your cheat sheet. And the only problem with this formula is that depending on how things are structured, sometimes how things are moving, the AX isn't always going to be cosine and the AY isn't always going to be sine. It really depends on how the triangle is set up and what angle how you're looking at it. And so by taking everything from this east right here, so for example, this is like 90 degrees, we know that. And so if we add up the total, it's going to be 90 plus 35 is going to be equal to 125. If we add up that total and then we just take this angle, we can always use cosine for x and sine for y. And in this way, you don't have to worry about subtraction because you're always doing addition. Because when you put this into your calculator, it'll automatically give you like a negative or a positive in the case that you need to do addition or subtraction. So I'm going to break this part down to where we're going to do A. So we have one side already, and now we're going to need to find kind of like the x component of A and then the y component of A. And so we got A is going to be equal to 75 kilometers. AX is going to be the formula that we started with over here. AX is going to be A cosine theta. In this case, since we already took the angle from each side, we can just use 125 and we don't have to worry about any kind of like negation or changing that cosine or to sine. Okay, 125 degrees. And similarly, once you have AX, you can kind of just think about AY. Is this going to be the same thing, but with sine? I'm sorry. Okay, so now we're going to do the same thing over here, but this for 2B is going to be easier since we already have it from 65. And so all you got to do is the same thing. B is equal to 155 km kilometers. Bx is going to be equal to B cosine theta. And then by is going to be equal to b sine theta. So here it's going to be 155 cosine 65, and here it's going to be 155 cosine, sine 65. Okay. So a lot of students will get here and then we'll get kind of stuck. And now we go back to the bigger picture, right? Which is why I have the ultimate triangle here. And it's like super cheesy, but I think it will help. So we have, let me pull out my highlighter. So we have bx right here, and then we also notice this ax over here. This ultimate triangle, you kind of think of it as here, as xy, and this is c, right? Triangle C. So this is cy, cx, and then c in general, c result. And so cx down here is going to be composed of this ax plus this bx. And also, I just want to say, you can start solving this already. I personally like to keep it in this form until I get to the bottom, so I don't have too many numbers running around, but it's personal preference and up to you. So this is going to be 75 cosine 125 plus 155 cosine 65. And I'm going to plug that to my calculator and see what I get. I'm going to go highlight that pink too, so that we know where we're getting these values from. I think once everything goes in, let's see, 75, 725. If you put this in, you'll see that it's like a negative value. So in a case like you usually probably would have ended up having to subtract that, but everything's just simplified now because it's just we took everything from the east. And so once we add this all up, we get 22.49 kilometers. And I know you're like trying sig figs, but sig figs. I like to keep everything kind of like longer, and then once we're at the end, I just kind of consider like how many sig figs and just adjust my answer for that. And it'll generally be all right. Okay, cy again, same thing, right? So we're just gonna add this by and this ay to get this cy. What am I doing? It's gonna be 75 sine 125 plus 155 sine 65. And then that is going to give you, I think I already have it solved out. It's going to give you 201.91 kilometers. So we have two very important components, but this is all just set up to answer our final question, which is what we're trying to solve for, the total displacement, which is going to be this C right here. It's okay. I've been like yapping, so can someone tell me like what you would use or how you would solve for C? Or you can just type it in the chat.
Would you do like the square root of the x's and the y's?
Yes, exactly. Okay. That is like perfect. Okay. So I'm like almost out of space, but I'm gonna create a little square right here, a little nook. Okay, C is gonna be equal to, again, like Vaughn said, that looks really crappy, but C y squared plus CX squared. And that would just be the things that we have the squared, not boxed, English boxed over here. So I'm not gonna plug it in because I'm almost out of space. Actually, I need to, just in case y'all go back to this and y'all something gets confused. Let me do that really quick. So, okay. I think once you put that into your calculator, you'll get something like 203 kilometers. So can anyone tell me what I'm missing at the moment? Like I've answered the question, I talked about the total displacement. Is there something I'm still missing, or is my answer done at this point? I'll answer. So since they're asking for displacement, the difference between distance and displacement is because like distance, you got your total distance traveled and you're not thinking about absolute value, right? But when you think about displacement, you're thinking about the absolute value, the magnitude of how much you traveled, but also there also implies a direction, right? Like when we talk about negative and positive, we're talking about direction. So in this case, this is a mistake I made on my exam. Like I just put the value and I was like, I'm done. I was not done. I needed an angle, right? So in addition to the value of the resultant side, you're also considering the angle and the direction it's going at. So that angle is your direction. I'm overcomplicating it, but yay, I have some more space. Okay, and so this formula is also another one that you'll have on your cheat sheet, or you should have on your cheat sheet. And to find the angle, it's very simple if you set up this ultimate triangle, right? So it's just going to be the angle. Lame. Okay. And it's just this formula right here that you've probably seen in class or on the PowerPoint and in the textbook. Y over X. If you want to be like more correct, the Y over CX, but Y over X is fine. Whatever you understand. But ultimately, it's just the blue over the pink. And so if you have these values laid out really nice and everything, you can just plug everything in for the values and you'll get your angle really nice and easy. You just kind of have to set everything up. And I think that's the hardest part. It's just like setting everything up. But once you have that clarified, then you're set. Okay. So your final answer will be something like final answer will be 203 kilometers at 83.64 degrees. And if you're wondering, like, why aren't we saying 83.64 degrees, like northeast or west of north? Honestly, I don't think she's gonna look for that. And so if she's not gonna look for it, don't kind of put yourself in a situation where you could make an error. Just put the degrees. Because what happens is that when we're solving, depending on where you take it, I don't know if y'all remember pre-calculus, but I don't, but when they talk about like coterminal angles and all that, sometimes that happens too when you're solving, and it just makes things different. So just put angle and see if she says you're set. So I'm gonna leave space for any questions, any really stunning confusions at this point. Anything I need to clarify or yeah. My meeting will end in 10 minutes, and so I'll resend everything out. Okay, so without further ado, now that we're done with this kind of vector addition, like I said, I don't know if everyone was here before, but likely since this exam is so material full, I'm expecting that she probably will not ask an explicit question like this, but rather it will be something to do with forces and just incorporating in some way to ask about forces. Okay. Don't want to do forces or 2D kinematics. Like anyone have a strong preference right now? Because I can do anything. Forces, okay. Do forces. I know that's a good transition too. Okay, we're gonna start off with a more straightforward one. And this is really kind of one system. There's not a lot going on. So this is just a block sliding down a frictionless plane with a angle of inclination. And it starts from breadth and it gives you the length of the inclined chute. And so we want a free body diagram, we want the block's acceleration, and we want its speed at the bottom of the incline. This is a very commonly tested problem. I don't know since she's making it so material if she's gonna go over this a lot or not, or if she'll just ask you a more complex force question. But I think it doesn't hurt to cover this at all. This is like this gear problem you saw in your textbook. But anyway, I'm talking too much. So I'm gonna give everyone like 5 minutes to solve this problem. Once we come back, we'll probably have 3 minutes to talk about it before I have to reboot the meeting. But 5 minutes starting. Okay. All right. That's 5 minutes. To be honest, I am right now, I'm kind of giving y'all like a little bit less, not a little bit, but it's like less time than you would probably take on the exam to solve this. I'm just gonna jump right into it so that we can just make sure we're all on the same path. So I kind of drew a picture here, a visual guide, and that's what I recommend you do if you ever have like kind of a block kind of plane on an incline. It just helps clarify things up. But let's jump right into it with the free body diagram. And so we have this box that's just sitting here. And we're told it's actually not sitting there. It starts to rest and then it starts moving. But right now we see that it's on a surface. And whenever anything's on a surface, anything's in contact with the table or sitting on anything, then you know that you're going to have normal force. And the normal force is going to be a little bit janky because it's not coming from any kind of plane, but it's coming from the plane of the angle of the plane that that object is resting on. And so in this case, we have normal force just like poking out here. And we can kind of see the perpendicular, right? Little right triangle right here. And we have one more force that's important to note. And that force is going to be gravity. And it's force gravity. Acceleration. Anyways, I'm sorry, not gravity, but that force is going to be our weight, right? So our weight is always going to be pointing downwards, straight down. So it's kind of like a little bit wanky, but we're going to go clarify this up. And so our free body diagram, if you're asked to draw a free body diagram, honestly, that's all you have to draw. It's just drawing this to help you figure it out. But honestly, when you actually have to draw, you can just kind of put FN and down you can put weight or FG, whatever you like to write, whatever works for your brain and makes it to where you aren't confused. Up to you. Just make sure you have a consistent system because it'll help you process information better. So this is all we have so far, but what we're going to do next is we're going to break it down. And so generally when we have a coordinate plane, we have less than a minute. I'm just going to end the meeting right now, and then we're going to start back on like the altered coordinate plane when we get back.